There is a widespread and deeply seductive assumption buried inside almost every conversation about interstellar travel. It is the assumption that space is fundamentally empty, that the vast and silent distances between stars are a kind of frictionless highway, an open void where a sufficiently powerful engine could simply push a ship faster and faster without meaningful resistance, without physical cost, without the universe pushing back. It is an assumption that feels geometrically obvious. You look up at a clear night sky, you see darkness between those brilliant pinpoints of light, and the mind naturally concludes that the darkness is nothing, that the space between is simply absence. That if you could build a ship powerful enough, a civilization advanced enough, you could one day cross it. That assumption is wrong. It is not wrong in a trivial engineering sense where the distances are merely large and the fuel requirements are merely extreme. It is wrong in a far more fundamental way. The universe itself has woven into its deepest physical laws a mechanism that actively, mathematically, and catastrophically punishes any macroscopic object that attempts to move through space at the velocities required for interstellar travel. The punishment is not a matter of degree, it is a matter of kind. And to understand it, you have to start not with the ship, not with the engine, not with the alien civilization, but with the light. Specifically, you have to start with the oldest light in the observable universe. Approximately 380,000 years after the Big Bang, the universe had cooled sufficiently for electrons and protons to combine and form the first stable hydrogen atoms. Before this moment, the cosmos was an opaque, superheated plasma. Photons, particles of light, could not travel freely. They were continuously absorbed and re-emitted, trapped inside a brilliant, seething fog. Then, as the temperature dropped to roughly 3,000 degrees Kelvin, the fog lifted, the photons were released. They streamed outward in every direction simultaneously, filling all of space with a uniform bath of radiation. That was approximately 13.8 billion years ago. Those photons are still here. They have been traveling through the expanding universe ever since, and the expansion of space has stretched their wavelengths dramatically, shifting them from the visible and infrared portions of the electromagnetic spectrum down into the microwave band. Today, they fill all of space with extraordinary uniformity. Every cubic centimeter of the observable universe, including the space between galaxies, including the space between stars, including the space your hypothetical alien starship would have to cross, contains approximately 411 of these ancient photons per cubic centimeter. We call this the cosmic microwave background radiation, and this is where the story gets profound. Consider a thought experiment. You are standing outside in a gentle rainstorm. The rain is soft, the drops are small, and the energy of each individual raindrop striking your skin is completely negligible. You feel nothing alarming. The rain is simply background noise, a mild ambient presence. You could stand there indefinitely and suffer no meaningful harm. Now imagine you are not standing still. Imagine you are inside an extraordinarily fast vehicle, moving directly into that same gentle rain at 20,000 miles per hour. You are not driving through more rain. You are driving through the identically same gentle rain. The rain itself has not changed. The energy of each individual raindrop in its own rest frame has not changed. But the physics of the collision has changed completely. From the reference frame of your vehicle, those soft, gentle raindrops are now striking the windshield with the kinetic energy of high-caliber bullets. The glass shatters. The vehicle is destroyed, not because the rain became more dangerous, but because your velocity transformed the nature of the collision itself. This is not a loose metaphor. This is a precise description of what special relativity dictates will happen to any object moving at a significant fraction of the speed of light through the cosmic microwave background. The photons of the CMB are the gentle rain. They carry very little energy individually. In the reference frame of the universe, a CMB photon has a wavelength of approximately 1.9 millimeters and a temperature equivalent of 2.7 degrees Kelvin. It is extraordinarily cold, extraordinarily weak radiation. Standing still in space or moving at ordinary velocities, a spacecraft would barely register its presence. The onboard sensors would detect it, certainly, but it would pose no more threat than background static. But now the alien civilization begins to accelerate. Their purpose is noble, and their technology is extraordinary. To reach even the nearest star system, they must travel at a velocity that represents a meaningful fraction of the speed of light. The distance to Proxima Centauri is approximately 4.2 light-years. To cross it in a time frame measured in decades rather than millennia, the ship must travel at somewhere between 10 and 90% the speed of light. And this is where the geometry of the universe begins to enforce its most unyielding law. As the ship accelerates toward the CMB photons streaming in from the direction of travel, those photons undergo a process called relativistic blueshift. This is the Doppler effect applied at relativistic velocities, and its consequences are not linear. They are exponential. The Doppler effect in its familiar form explains why an ambulance siren sounds higher pitched as it approaches you. The sound waves are compressed in the direction of travel. Their wavelength shortens. Their frequency increases. Their energy rises. The same phenomenon applies to electromagnetic radiation. As the alien ship moves toward the incoming CMB photons, those photons are compressed. Their wavelengths shorten. Their frequencies increase. Their energies rise. The critical insight is the rate at which this happens. At 10% the speed of light, the blueshift factor is modest. The CMB photons striking the front of the ship have their energies increased by a relatively small multiplier. They shift slightly up the electromagnetic spectrum from microwaves toward infrared. The ship experiences somewhat elevated radiation, manageable with appropriate shielding, nothing catastrophic. At 50% the speed of light, the blueshift factor increases substantially. The photons strike with significantly higher energy, shifting further up the spectrum toward visible light and ultraviolet. The radiation environment becomes genuinely hostile. The engineering challenge is serious. At 90% the speed of light, the mathematics become brutal. The blueshift factor approaches a value where the ancient microwaves have been compressed into hard X-rays. The energy of every single CMB photon striking the forward hull has been multiplied by a factor of several, and the flux, the number of photons hitting the ship per second, has also increased dramatically because the ship is rushing toward them. The forward surface of the ship is now being bombarded by hard radiation that no known material can passively withstand indefinitely. At 99% the speed of light, the transformation is complete and catastrophic. The blueshift factor at this velocity, derived directly from the Lorentz transformation that sits at the core of special relativity, multiplies the energy of incoming CMB photons by a factor of approximately 14. These are no longer microwaves. They are no longer X-rays. They have crossed the threshold into gamma radiation, the most energetic and penetrating form of electromagnetic radiation in the known universe. The gentle, ancient whisper of the cosmic microwave background has been geometrically transformed into a continuous, unrelenting gamma-ray bombardment targeting the front of the ship. And gamma radiation does not merely heat a material, it does something far more destructive at the molecular level. Every material that has ever been engineered, regardless of the civilization that produced it, is held together by chemical bonds. At its most fundamental level, the structural integrity of matter depends on the electromagnetic force binding electrons to atomic nuclei and binding atoms to one another in the lattices and networks that give solid objects their properties. These are covalent bonds, ionic bonds, metallic bonds, all variations on the same underlying electromagnetic architecture. They have characteristic energies, typically in the range of a few electron volts. These are the energetic foundations of chemistry, of materials, science, of every physical object that has ever existed. A gamma-ray photon produced by the relativistic blueshift of CMB radiation at 99% the speed of light carries energy measured in mega-electron volts, potentially hundreds of thousands of times the energy of the bonds holding matter together. When such a photon strikes an atom in the hull of the alien ship, it does not merely vibrate the atom, does not merely heat the material. It ejects electrons from atoms with extraordinary violence in a process called the photoelectric effect. At sufficient energy, it produces electron-positron pairs through pair production. At the highest energies, it initiates electromagnetic cascades where a single gamma-ray photon generates a shower of secondary particles that propagate through the material, each secondary interaction breaking more bonds, ionizing more atoms, disrupting more molecular structures. The hull is not slowly heated. It is chemically and structurally unwoven at the atomic scale, from the outside in, continuously and without interruption, for as long as the ship maintains its velocity. There is no known material that can passively withstand this. Not conventional metals, not ceramics, not carbon fiber composites, not hypothetical exotic materials whose properties we can mathematically describe but have not produced. The constraint is not technological, it is thermodynamic. The energy deposited by the gamma-ray flux at relativistic velocities exceeds the binding energy of matter itself. You cannot engineer around a force that exceeds the fundamental energetic threshold of chemical bonds. And we have not yet discussed what happens when the ship does not merely encounter CMB photons. Space is not purely populated with ancient background radiation. The interstellar medium contains free protons, hydrogen atoms, helium nuclei, and trace quantities of heavier elements. At non-relativistic velocities, these particles pose no meaningful hazard. They are sparse, and the energy of a collision between a stationary particle and a slow-moving hull is negligible. At relativistic velocities, the same transformation that weaponizes the CMB applies to every particle in the interstellar medium. A free proton at rest that the ship plows through at 99% the speed of light does not experience the ship as a solid surface approaching at high speed. The proton experiences itself being struck by a hull carrying an enormous relativistic mass and momentum. The collision energy in the center of momentum frame is sufficient to initiate hadronic interactions, particle physics processes that produce pions, muons, and other secondary particles that penetrate deep into the ship. This is directly related to what physicists call the Greisen-Zatsepin-Kuzmin limit, a theoretical threshold in cosmic ray physics first proposed in the 1960s. When cosmic ray protons travel through space at extreme energies, they interact with CMB photons through a process called pion photoproduction. The collision energy is sufficient to produce pi mesons, and this process strips energy from the cosmic ray particle with extraordinary efficiency. Protons, accelerated to energies above a certain threshold, lose that energy almost completely within a travel distance of roughly 160 million light-years. The universe itself imposes an energy ceiling on particles propagating through the CMB. An alien starship is, in the thermodynamic and physical sense, a macroscopic particle. The same underlying physics that enforces the GZK limit on cosmic ray protons applies through the same basic interaction mechanics to any object moving at comparable velocities through the same radiation field. The numbers differ because the object is far more massive, and the relevant processes are different in detail, but the fundamental principle is geometrically identical. High velocity through the CMB converts that background radiation into a hostile energetic environment, and the environment does not negotiate. Now consider what conservation of momentum requires. To reach 99% the speed of light, the ship must have acquired an enormous amount of kinetic energy. The Lorentz factor at this velocity is approximately 7. This means the ship does not merely carry the kinetic energy of a mass moving at 99% light speed in the Newtonian approximation. Its effective inertia, its resistance to changes in velocity, is 7 times greater than its rest mass would suggest. The fuel expenditure required to reach this velocity is not merely large. Under the rocket equation, the ratio of propellant mass to payload mass required grows exponentially with velocity. Long before approaching the speed of light, the required fuel mass exceeds any realistic bound. An alien civilization, however advanced, operates within the same conservation laws. They cannot create energy. They cannot evade the rocket equation. The momentum must come from somewhere. Every gram of fuel they expend to accelerate the ship must also accelerate all remaining fuel. The tyranny of the rocket equation does not weaken as engineering improves. It is a mathematical constraint, not an engineering shortcoming. And then, having paid that staggering energetic cost, having crossed the threshold into the gamma-ray bombardment zone, having watched their hull begin to structurally fail Under the continuous assault of photons carrying energies that unravel covalent bonds, they face the second half of the journey. They must decelerate. Every bit of velocity they accumulated must be removed before reaching the destination. The energy expenditure is not halved by this realization, it is doubled. The ship must carry fuel not only for acceleration but for deceleration, and the deceleration fuel itself must be accelerated during the acceleration phase, compounding the rocket equation's demands catastrophically. What emerges from this rigorous physical analysis is not a story about the limitations of engineering. It is a story about the geometry of the universe itself. Space is not empty. It is filled with the ancient thermodynamic residue of its own origin, a background radiation field that is perfectly harmless at ordinary velocities and transforms into an absolute physical barrier at the velocities required for interstellar travel on any meaningful timescale. The alien civilization that built a starship powerful enough to reach relativistic velocities did not fail because their engines were insufficiently powerful. They failed because the universe mathematically converted its own ambient background into a weapon targeted specifically at the physics of high-velocity travel. The CMB did not change. The laws of electromagnetism did not change. The Lorentz transformation did not change. The ship simply moved fast enough that the geometry of relativity expressed its full and merciless consequences. There is something worth pausing on here. The cosmic microwave background is the afterglow of creation itself. It is a fossil record of the universe at its earliest accessible moment, the light released when matter and radiation first decoupled, the oldest electromagnetic signal we can detect, a relic of conditions so extreme that nothing analogous has existed in the 13 billion years since. And the same ancient light that tells us more about the birth of the universe than virtually any other observation also serves as an impenetrable physical barrier against any macroscopic object attempting to move fast enough to cross the stars. The universe does not merely permit physics, it enforces it. And the enforcement is elegant and ruthless, and perfectly consistent with itself down to the last decimal place. This is not a story that ends with hope for a technological workaround. Warp drives and wormholes are mathematically speculative in the deepest sense. Warp drives require exotic matter with negative energy density, a substance with no confirmed experimental existence. Wormholes require similarly exotic physics and, even if they existed, would likely be dynamically unstable against quantum fluctuations. These are not engineering challenges awaiting clever solutions. They are theoretical constructs whose physical realizability remains, at best, deeply unclear. And the fermiparadox, the question of why we see no evidence of other civilizations given the vast age and scale of the universe, gains new texture in this light. Perhaps the silence is not a puzzle requiring exotic explanation. Perhaps it is the expected and natural consequence of the universe being built the way it is. A civilization confined to the vicinity of a single star is not failing to explore, it is obeying physics. The distances are not merely large. They are protected by the background radiation of the cosmos itself, a perfect, uniform, all-pervasive field that grows more deadly the faster you attempt to cross it. The universe keeps its secrets behind a wall of ancient light, and the wall is not weakened by intelligence, by technology, or by the ambition of any civilization that has ever looked up at the stars and wondered what lies beyond.